Hello, everyone. My name is Vanessa Zepeda, and I'm currently a PhD student at the Queensland University of Technology. I just moved to Brisbane March last year, good timing, I know, from Hawaii, where I earned both my bachelor's and master's degrees. It was during my master's project when I fell in love with astrobiology. I had two internships with NASA's Jet Propulsion Laboratory in Pasadena, California, where I was working with organic molecules in ancient rocks and meteorites. And it was through that experience that I ended up here in Australia to pursue my PhD. Today, I'm going to chat with you about my research, investigating the origin of organic matter in hydrothermal systems of the Archean. Before I get started, I would like to acknowledge the Indigenous peoples of my study site at the Pilbara Craton. I wish to pay respect to the elders of Aboriginal and Torres Strait Islander societies, both past and present, and further acknowledge the important role that Indigenous people continue to play within Australian communities. Astrobiology is an interdisciplinary science that focuses on the origin and evolution of life on Earth, with an overall goal of using this information to search for evidence of past or present life elsewhere in the universe. The rock record on Earth dates back to the Archean Eon, which spans 4 to 2.5 billion years ago, around the time that life was establishing on our planet. Therefore, Archean rocks are of great significance for astrobiology research. Stromatolites are some of the oldest evidence for life on Earth during this geological time period. Western Australia is one of only two places left on Earth that retain a sedimentary record of the Archean. My study site, the Strelley Pool Formation, is located here in Western Australia. The 3.4 billion-year-old Strelley Pool Formation, or SPF, is representative of an ancient shallow water environment and contains fossilized evidence for life on Earth, stromatolites, which are laminated structures of biological origin. Additionally, hydrothermal chert veins cross-cut the region. The dike depicted in the center image terminates within the Strelley Pool Formation and was exhaling hot fluids into the shallow water marine environment during the deposition of the SPF and the accretion of the SPF stromatolites. The SPF lies stratigraphically between the Urobasalt and the Panorama Formation. The aerial photo on the right shows the hydrothermal chert veins that cross-cut the Strelley Pool Formation. The presence of stromatolites of biological origin and hydrothermalism make it an ideal place to address the current debate surrounding the origin of organic matter found in Archean hydrothermal systems. The origin of organic matter in Archean hydrothermal systems is highly debated. Organic matter does not necessarily mean of biological origin. Methane and other hydrocarbons are a prime example. Currently, there are two main explanations for the origin of organic matter found in Archean hydrothermal cherts. One, as the products of abiotic processes, such as Fischer-Tropsch synthesis, or FTS, or the organic matter is from the remains of ancient life. FTS forms organic molecules such as hydrocarbons via water-rock interactions. Essentially, the process starts with carbon monoxide attaching to a catalyst surface to produce methane, and then subsequently adding carbons to form larger hydrocarbons until terminated by hydrogen. Other arguments suggest that organic matter is of biological origin. The presence of stromatolites and bacterial microfossils in the Strelley Pool Formation could have been redistributed and sequestered to great depths via a newly proposed hypothesis called the hydrothermal pump hypothesis. Differentiating between these two processes is challenging because both processes fractionate the stable isotopes of carbon so that the organic matter ends up significantly depleted in carbon-13. I hope to address the following research questions. What paleo-environmental conditions were present during the deposition of the Strelley Pool Formation and associated dike system? Is organic matter present in the Strelley Pool Formation hydrothermal dike system characteristic of abiotic formation, biological origin, or a combination of both? If organic matter is characteristic of abiotic formation, what is the distribution of metal catalysts or organic precursors that can catalyze Fischer-Tropsch synthesis? If the organic matter is biological in origin, what metabolisms were present? And finally, can fractionation of nickel isotopes be used as additional indicators of methanogenesis in the Archean? I will use several techniques to address these research questions. To understand the characteristics of the hydrothermal system, extensive petrography of thin sections will help me identify mineral phases as well as textural information. To further investigate the paleoenvironmental conditions, ICP-MS can provide information about water sources, hydrothermalism, and temperature. Additionally, laser Raman and scanning electron microscopy will help me identify and image organic domains, structures, and mineral phases. To investigate what metabolisms are present, bulk stable isotope analysis of biologically significant elements such as carbon, oxygen, and sulfur will also be investigated using isotope ratio mass spectrometry. These are photomicrographs of laminated structures in thin section, 350 meters below the paleo seafloor. These could possibly be the remnants of microbial mats that were ripped from the seafloor and redistributed by hydrothermal pumping. Initial Raman spectra of the laminated structures show peaks that are characteristic of disordered organic matter. Notice the wide D and G bands. Raman spectra of organic matter has been used as a paleothermometer and is currently being investigated to determine the temperature changes with depth from the paleo surface. The pilot bulk rock rare earth element geochemistry shows the most pronounced marine features typical of a seawater source at greatest depth, 863.34 meters below the paleo seafloor. Characteristic features include positive lanthanum and yttrium anomalies and general heavy rare earth element enrichment. However, XRD and petrographic analyses reveals the presence of carbonate in the chert veins. This not only suggests an alkaline pH of the hydrothermal system, but also bears the possibility that chert and carbonate-hosted rare earth elements could have separate sources. New data are being generated for the chemically separated phases to verify whether the deepest chert indeed possesses the most marine rare earth element character. For future research directions, I plan to utilize SIMS, which is secondary ion mass spectrometry, in order to measure isotope fractionations in situ. This will be used to target biologically significant elements such as carbon, as well as sulfur, since pyrite has also been identified in thin section. I also plan to use SIMS to target metal domains, particularly to explore the fractionation of nickel isotopes. Nickel is an important element for methanogenesis, which is an extremophile metabolism that phylogenetically predates photosynthesis. I hope to explore whether nickel fractionations can be used as an indicator of methanogenesis in the Archean. Another aspect of my PhD will produce the first mineralogical, geochemical, and oxygen isotope data for variably altered basalts of the Ontong Java Plateau, which is analogous to the basalt directly underneath the Strelley Pool Formation. This will produce a new model for the evolution of ocean chemistry in the Archean. In conclusion, understanding prebiotic conditions present when life is being established on Earth allows us to investigate the conditions needed for life. This not only informs the origin of life on Earth, but can also be used in investigations searching for life elsewhere in our solar system, such as Mars. I would like to acknowledge and thank my supervisors, Dr. David Flannery, Professor Bowles Camber, and Dr. Ken Williford for their knowledge and guidance with this project. Thank you for your attention, and I'm open to any questions you may have.